Aerodynamic forces are generated and act on a rocket as it flies through the air. Forces are vector quantities having both a magnitude and a direction. The magnitude of the aerodynamic force depends on the shape, size, and velocity of the rocket and its components. The drag force, which is opposed to the direction of motion, and the lift force, which acts perpendicular to the direction of motion, which is out of the atmosphere. The lift and drag act through the center of pressure, which is the average location of the aerodynamic forces of an object. Aerodynamic forces are mechanical forces. They are generated by the intersection and contact of a solid body with a fluid, a liquid, or a gas. Aerodynamic forces are not generated by a force field in the sense that gravitational field or an electromagnetic field. For lift and drag to be generated, the rocket must be in contact with the air. So outside the atmosphere, there is no lift and no drag. Aerodynamic forces are generated by the difference in velocity between the rocket and the air. There must be a motion between the rocket and the air. If there is no relative motion, then there is no lift and no drag, and the rocket won't go anywhere. Aerodynamic forces are more important for a model rocket than a full-scale rocket because the entire flight path of the rocket takes place inside the atmosphere, whereas a full-scale rocket climbs above the atmosphere very quickly. Aerodynamic forces are used differently on a rocket than on an airplane. On an airplane, lift is used to overcome the weight of the aircraft, but on a rocket, thrust is used in opposition to the weight because the center of pressure is not normally located at the center of gravity of the rocket, which is right in the middle. Aerodynamic forces can cause the rocket to rotate in flight. The lift of a rocket is a side force used to stabilize the control and direction of flight. Lift occurs when the flow of gas is turned by a solid object. The flow is turned in one direction and the lift is generated in the opposite direction. According to Newton's third law of action and reaction, for a model rocket, the nose cone, the body tube, and the fins can turn and flow and become the source of lift if the rocket is inclined to the flight direction. While most aircrafts have high to lift drag ratio, the drag of a rocket is actually much greater than the lift.
Chemistry is at the heart of making rockets fly. Chemical rocket engines uses a fuel, which burns, and an oxidizer, which reacts with the fuel. Together, they're called the propellant. So, as the propellant reacts inside the combustion chamber, the chemical reaction produces hot gases. It is the ejection of these hot, expanding gases at high speed from the rocket nozzle that creates thrust. The fuel and oxidizer can be stored as solids, liquids, or hybrid, which is a combination of solid and liquid. So in a solid fuel engine, the fuel and the oxidizer, they're already mixed, and they're set as a solid inside the combustion chamber. So this solid is called the propellant grain. The rate at which the chemical reaction takes place depends on the type of fuel chosen and the surface area of the exposed grain. So inside the length is normally hollow, and this increases the amount of grain exposed and available to react. This can be linked to the chemical kinetics topic in the chemistry syllabus and the collision theory, where the size of the particle affects the rate of reaction. So the rate of the chemical reaction can be raised by increasing the surface area of a solid reactant, and therefore more particles are exposed to the reactant. There are more collisions, and the rate of reaction increases. Liquid propellant rocket engines uses a liquid fuel, such as liquid hydrogen or kerosene, and liquid oxidizer, such as liquid oxygen. These are stored in separate tanks and then pumped into the combustion chamber as required. As they are sprayed into the combustion chamber through injected nozzles, they rapidly mix together and react before being injected. One advantage of a liquid fuel system is that the amount of thrust can be controlled. This is done by limiting how quickly the fuel is pumped into the combustion chamber.
Human factors are necessary when it comes to studying space. But how are the lives of astronauts maintained when exposed to the conditions of outer space? Truly, they are not fully exposed. Engineers have created technologies that help maintain the necessities required for human life in outer space. But what is required for humans living in outer space? How do they survive that journey? To remain in stable, healthy conditions. It provides lack of dehydration, no dry organs. It helps in the processes of digestion and waste product removal, and it also helps with keeping our joints and spinal cords protected. Water is made on the spaceship itself and recycled. Carbon and oxygen are also vital molecules required for human life, and they help in the process of cell respiration. All of these are transported onto the spaceship through lightweight recyclable carriers, as well with freeze-dried and dehydrated foods. Your body is likely to change. Body fluids will move around, creating your face and eyes to swell. It is also likely that your bone density will decrease and muscle shrinkage can occur. Deep space radiation can cause cataracts and cancer with lasting effects. You have to take these risk factors into careful considerations. That's why in the International Space Station, exercise equipment is safely transported for the astronauts so they can stay in a fit health condition, as well as not notice any significant losses in health. Keeping your muscles moving helps in the production of ATP and blood flow regulation. In the International Space Station, it has become the perfect hub for humans occupying space.
Extraterrestrial life is the life that happens outside the Earth, a life which has not been created on Earth's planet. This virtual life may range from simple primordial nuclei or similar forms of life to organisms with much more advanced civilizations than humanity. The concept of extraterrestrial life, especially extraterrestrial intelligence, had a great cultural impact, especially in science fiction. Over the years, science fiction has presented a number of theoretical ideas, each with a wide range of possibilities. The Drake question speculates about the existence of intelligent life somewhere else in the universe. The science of extraterrestrial life in all of its forms is known as astrobiology. Astrobiology, previously it was known as exobiology, and it is an interdisciplinary scientific field concerned with the origins or early evolution, distribution, and future of life in the universe. Astrobiology considers the question whether does extraterrestrial life exists or not, and if it does, how can humans detect it? Astrobiology makes use of molecular biology, biophysics, chemistry, biochemistry, astronomy, physical cosmology, extraneous planets, and geology to explore the possibility of life on the other worlds, and helps to identify a biosphere that might be different from those on Earth. Origin and evolution of early life is an integral part of biology discipline. Astrobiology is concerned with the interpretation of existing scientific data, and although speculation is thought to give context, astronomy is primarily concerned with the hypotheses that are suitable to current scientific theories. These multidisciplinary fields include the search for the origin of planetary systems, the origins of organic compounds in space, the interactions between water, rock, carbon, biocontrol on the ground, planetary habitat, biogeographic research on life, and studies on the possibility of life to adapt a challenge on Earth and in space external.
We hope you had fun in this video and you found it informative. We hope to teach you more in the future. Keep aiming high to space! Woo!
Bye! Thank you for watching.